Alright, hi pre-calc class. One more quick video on how to graph the tangent function today. So remember the tangent function, if we're looking at the parent function, it looks like a cubic function and then has asymptotes separating each one. Right, so that's what we're going to be drawing. So first, we're going to identify not the amplitude, but what we call the inflection points, which will be is found in the same place as the amplitude. So if you have y equals a tangent b of x, or bx, a is going to give you your inflection point. And so what that means is that where you would draw in an amplitude, there's going to be a point there, and I'll show you how to use that in a minute to plot those. Then we're going to identify the period, which instead of 2 pi over b is pi over b, because we're only using, if you remember, the period of the tangent function is only using pi spaces, not 2 pi. At the beginning and at the end of each period, we're going to draw a 0. So if the period is 1 pi, then we'll have a 0 at 0, and then a 0 at 1 pi, and then a 0 at 2 pi, and that would continue. So every pi spaces we would have a 0. If the period were smaller or larger, you would do it at whatever intervals that would happen at. Halfway between each 0, so between 0 and pi, we're going to draw in the asymptotes. And then we will be connecting our graphs from low to high through those inflection points. So I'll show you where that comes in a minute to get our tangent graphs. Okay? So let's try one of the ones we have in your practice. Let's try y equals tangent of 2x. Okay? So first, our a value is 1. So I'm still going to mark it here at 1 and -1. That's going to be helpful to me later. That was really not straight, so let me try that again. Just like in class, I can't draw a straight line. Okay. So 1 and -1 is where I marked the amplitude values. Again, it's not really an amplitude, but it's going to help us with our curve in a minute. And then the period is going to be pi divided by b, which in our case, b is 2. So pi over 2. So at 0, and then again at pi over 2. And then again, we would have, if I keep going in pi over 2 increments, I'd have pi, and then 3 pi over 2. All right, and I'll stop there. So our direction said at every 0, at the beginning and the end of each period is a 0. So every pi over 2 spaces is a 0. And halfway between each of those zeros is an asymptote. So I'm going to draw in that imaginary boundary. So we've sort of blocked off our graph here. All right. And so now, with the tangent function, your curves are going to go low to high, unless it's negative tangent, and then they would go high to low. The inflection points help us figure that out. So if I know that I need this graph to go low to high, well, that means between where I put this 0 and where this asymptote is, it's really large. Can we see? Here's the asymptote, here's the asymptote, here's the asymptote. So between where I put the 0 and where this asymptote is, the graph is going to hit this inflection point, I'll call it, right about there. And then as it goes up, in between this 0 and this asymptote, it's going to hit again. So we get more of a value like that. So the amplitude still helps us, even though it's not actually a boundary. And that process continues. And I know these aren't going to be perfect, so just do your best to get that curve correctly in there. And as long as I can see at least one full period, that's okay. All right, so that's your process. Figure out the amplitude value, and it's not really an amplitude, but it gives us this extra point here. So go ahead and mark those in. Find your period at the beginning and end of each period. So 0, pi over 2, pi, 3 pi over 2, you have a 0. Halfway between those, you have asymptotes, and then connect your graph low to high. Right, so go ahead and try